After the completion of the module, you will be able to describe SCCP functionality, describe SCCP messages and formats, explain global title, GT, and global title translation, GTT. SCCP enhances MTP to meet OSI Layer 3. It provides powerful and flexible routing mechanisms in the form of subsystem and global titles. SCCP enhances message transfer capability, including segmentation and reassembly when message is too large to fit into one message signal unit, MSU. Theoretically, the maximum amount of user data is 3952 octets in ITUT SCCP and 3904 octets in ANSI SCCP. SCCP supports connectionless and connection-oriented data transfer services. SCCP also controls management and addressing of subsystems, primarily for database-driven applications. The various SCCP services are SCCP Connection-Oriented Control, SCOC, responsible for setting up and releasing a virtual connection between two SCCP users. SCOC can offer features including sequencing, flow control, and segmentation, and can override congestion procedures by assigning data priority. SCCP Connectionless Control, SCLC, responsible for transferring data between SCCP users without creating a virtual connection. SCCP Routing Control, SCRC, provides additional routing beyond that offered by MTP3 through the use of global titles. SCCP Management, SCMG, responsible for tracking application status and informing SCMG at other SCCP nodes, as necessary. The SCCP provides two categories of service for data transfer: connection-oriented services and connectionless services. Within each service category, two classes of service are defined as follows. Class 0. Basic Connectionless Class. This class of service is used in communication with database-driven applications. In this scenario, only query and responses are exchanged, and therefore, no requirement of dedicated connectivity. Class 1. Sequence Control Connectionless Class. This class of service is used in exchange of SCCP management message, where sequencing is required in specific scenarios. Class 2. Basic Connection-Oriented Class. This class of service is required when SCCP services are used for call-related procedures. Here, dedicated connectivity required for data transfer. Class 3. Flow Control Connection-Oriented Class. This class of service is required while applying congestion control during connection-oriented data transfer. Some enhancements to messages transfer are: MTP uses the service indicator, SI, in an incoming message to deliver it to the appropriate MTP user. SCCP is one of them. SI has a range 0 through 15, limiting the number of MTP users to 16. SCCP expands the addressing capability of SS7, allowing up to 127 subsystems at a signaling point. SCCP also allows a calling subsystem to address a called subsystem by a global title, GT. This is a functional address in the form of a digit string that cannot be used for message routing. SCCP includes provisions to translate a global title into an address that can be used to route a message to its destination subsystem. ITU specified SCCP message are for SCCP connection-oriented service. The messages are connection request and connection confirm to establish a connection. Released and release complete messages to release a connection. For data transfer, DT message of Form 1 and 2, as per the class of service used. For SCCP connectionless service, no connection is required. Data is exchanged using unit data message. UDTS message is sent to originating SCCP when return error option is marked in outgoing UDT message, and UDT message could not be delivered to terminating SCCP. Apart from the absence of a circuit identification code (CIC) field following the routing label, the basic message format is the same as an ISUP message. As with all other MTP users, SCCP messages are composed of 3 parts: a mandatory fixed part, mandatory variable part, and an optional part. All SCCP messages contain a mandatory fixed part, but not all of them have parameters to place in the mandatory variable or optional part. Here, we present an example of SCCP message format. Format of connection request is presented. Message type is marked as CR. Source local reference and protocol class are mandatory parameter values. Called party address CDPA is mandatory variable parameter. Therefore, its length and content is mentioned. This is followed by optional parameters of credit, calling party address CGPA, etc. is mentioned in tag, length, content format. Here, we present the format of SCCP addressing. It contains any combination of point code, PC, subsystem number, SSN, and/or global title, GT. Octet 1 indicates the presence or absence of PC, SSN, and GT in the address. Octets 2 through N contain the value of PC, SSN, and GT, if included. Point code indicator, PCI. This indicates the presence, 1, or absence, 0, of point code. Subsystem number indicator, SSNI. This indicates the presence, or absence, of subsystem number. Global title indicator, GTI. If GTI equals 0000, no global title is present. If GTI is 0001, 0010, 0011, or 0100, a GT is present. The global title format depends on the value of GTI. Routing indicator, RTI. If the called address includes a global title, the sending SCCP specifies with RTI how the receiving SCCP should route the message. RTI equals 0. Global title translation should be performed, and routing should be based on the translation result. RTI equals 1. GT translation should not be performed, and routing should be based on the destination point code, DPC, in the MTP routing label of the message. Point code, PC. The point codes in ITU-TSS7 signaling and ANSI number 7 signaling have, respectively, 14 and 24 bits. Subsystem number, SSN. The 1-octet SSN field identifies the SCCP user subsystem. Explanation for global title is given in the subsequent slide. A global title is a functional address of a subsystem in an exchange or database. The global title contents consist of the translation type, TT, and the global title address, GTA. The presence, P, or absence, A, of the octets with individual parameters, is indicated by the value of GTI. Global title always includes GTA consisting of a digit string. Translation type, TT. Most GT translations yield a point code and subsystem number of a called subsystem. TT specify the type of translation to be performed. The TT values in a particular network are established by the network operator. Global title translation is conversion of functional digit string to point code and SSN. It is usually performed by special STPs, which have the logic and information of translating the number and routing the message to correct node for further processing. Here we take an example of 800 number translation. Q800A is a query application present in Exchange A. R800C is a response application present in database C. Suppose that the setup of a call with a called 800 number, say 800-123-4567, has reached Exchange A. Exchange A has to resolve the 800 digits to a routing number, only then can proceed with the call setup. Query message. The Q800A launches a query to a database to obtain the routing number for the call. We assume that the call routing information for this particular 800 number is stored in R800C at databases C. TCAPA has received the calling and called address, CDA, CGA, from Q800A, and includes them in the NUnit data request to SCCPA. The CDA is a GT, in which the translation type is T, and the address is N, which is the called 800 number. The translation type indicates that N has to be translated into the PC and SSN address of an R800, at a database with information on that number. SCCPA enters GT in the CDA portion of the unit data message, with point code as A, SSN as Q, and sets the routing indicator to RTI as 0, indicating that a GT translation is needed. Since SCCPA has received the GT called address, and knows that the SCCPB can perform GT translations, it includes the MTP address of signaling point B, DPC as B, when passing the message. MTPA then forms the MSU and transfers it to STPB. SCCPB translates the GT, and obtains the addresses PC as C, SSN as R of R800 units at database C. It enters SSN as R in the CDA of its outgoing message, and passes it to its MTPB, that includes destination point code DPC as C. It also sets the routing indicator to RTI as 1. SCCPC receives the message and passes it to TCAPC, which includes the calling address PC as A, SSN as Q. Finally, TCAPC delivers the message to R800C. Response message. R800C uses the received CGA, point code as A, SSN as Q, as the CDA for its response message. The transfer of the message to SCCPA is done by MTPs exclusively, no GT translation needed. At Exchange A, subsystem number SSN equals Q and the CDA is used to deliver CGA, and the routing number for the call, in the subsystem data field, to Q800A. Exchange A then routes the call to its destination as per the routing number received. To summarize, SCCP enhances MTP to meet OSI Layer 3. It provides powerful and flexible routing mechanisms in the form of subsystem and global titles. SCCP also controls management and addressing of subsystems, primarily for database-driven applications. SCCP enhances message transfer capability, including segmentation and reassembly, when message is too large to fit into one message signal unit, MSU. Theoretically, the maximum amount of user data is 3952 octets in ITUT SCCP, and 3904 octets in ANSI SCCP. SCCP supports connectionless and connection-oriented data transfer services. Examples of connectionless services are interaction with database applications and SCCP management services. Examples of connection-oriented services are where SCCP is used for call-related procedures, or to transfer on-bulk call-related data in GSM networks. This completes the module. Click Next Topic from navigation menu.